All right, folks, we can get started. So it looks like last time we left off on counting specific items. Just a brief refresher on this. This is talking about the count method that's built into the list data type. Count is a method of lists. It's also a method for other types that have things that we can take account of, right? So something that can contain duplicates, so strings, tuples, lists, we can use count in the same manner, and we can count whatever we're looking for. So just a quick example here. So if we print this, we'll just print this list out first. This is just going to have a list of 5 sevens. Oops. What? Huh. How'd that get there? Okay. Straight character. Oops. We'll just print this list out. Sorry. So you can see this line 3, this creates a list with 5 sevens in it, and then we get a list, 5 sevens in it, and then we count the number of sevens and we get 5. I just wanted to revisit this because it's a really useful method that you can use in a lot of different contexts. So, looks like we already have a question here. Challenge number 3, we've got a link and some code. Thank you to the question asker. Okay. Now I'm going to paste in the code that was provided for me. And we'll take a look at it. I'm going to see if I can try to get this code to work first. And then I may write a different solution. I might take a different approach and write my own solution. The sound is kind of low. Okay. Sorry, I'm going to turn up my volume a little bit. I'm trying to make sure that the volume doesn't peak. Sometimes I listened back to several of the other streams and it was peaking pretty bad, so. Test, 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 test. Test, test, test. Check, check, check. Right about there. Okay, that'll be about good. Is that better? Sorry for that. Thanks for letting me know, though. All right. If it's, by the way, if it's quiet, that's about as loud as I can make it go without overdriving the mic, it looks like. So that's about as much gain as I can get on this end. All right. Let's take a look at this code. First, let's take a look at what this code is supposed to do. Okay, good to know. Thank you. Thanks for confirming that. Okay, write a function called letter IDX. That will track the indices of where the vowels occur in the string. This function should take a word or a sentence as an argument, return a dictionary. The keys represent the vowels that occur in the sentence, and the values represent the indices where that vowel occurs. Okay, so values representing the indices where that value occurs. So what's interesting here is it doesn't actually say what the type of the value should be. I'm presuming it's a list, since what it's saying is the values should represent the indices. Since it says indices, we have like multiple indices. So the thing that I can think of that would work for that would be a list. You could also do a tuple. Oops. You could also do a tuple, or yeah. Those, yeah. Anyways, that's what makes sense for me. So I'll do a list where the values occur in the word or the sentence. For this exercise, the letter Y is considered a vowel. So for example, okay, so here we go. This gives us, this is a little example. So we have a free little test provided. We'll take that arrow, replace it with a hash. And so this confirms what I thought. We'll just print out this. And I said it confirms what I was thinking, because if we look at this, we have a dictionary and where the keys are values, the strings that are the values, and then the values of each key are a list of integers, presumably representing the index where each vowel occurs. So let's just verify that. So the output for this input is E, and it says E occurs at index 1, 8, and 10. So let's just verify that. So we have index 0, 1, 1 is an E. Let's see, 2, 3, 4, 5 is that space. 6, 7, 8 is an E right there. Oops. 9, 10. 10 is another E right there. So 1, 8, 10. That looks like what we got. And then index says O appears at index 4. So if we do 1, 2, 3, 4, there's that O at index 4. And I started counting at that E because I knew E was 1 there. So that's why. If you're thinking, why did I skip 0? I just started off at the E, which is index 1. Okay, cool. So this is the correct output that we expect for this input. And I'm checking this less to verify the integrity of this example. Like, I trust that this example is going to give me the right output here. But more so, I'm doing this just to show you, let's say I was just making up my own example. I could just feed it a simple string and then just kind of count where the vowels are and then write up a dictionary that I would expect for this small string. Cool. All right, so let's actually run the code. I haven't modified the original code in any significant way. I think I might have added a space or something in here, done a little formatting. But this is the original code that was sent, so let's just run it and see what happens. Okay, so this says 1, 4, 8, 10, and 1, 4, 8, 10. Okay, so I see what's happening here. 1, 8, 10, and 1, 8, 10 is for E, and 4 is for O. So it looks like we have a dictionary, which is correct. The dictionary has vowels as keys, which is correct. It has the correct keys, and the keys have a list with the correct indices, but the list is the same for each key, and the list includes all of the indices for all of the vowels rather than just the indices for the specific vowels that are in here. So I already think I suspect I know what's happening without even having, I've looked at the code and that it's in my text editor, but I haven't really meaningfully read through it yet. But I suspect I know what's happening already. So let's just confirm that. So I suspect that we're just creating a accumulator list for all of the vowels. And what we want to do is we want to create an empty list in each key, and then append to the appropriate list at each key. So let's just verify that. So I see IDX list. I suspect this is the list that is being assigned to each key here. So let's just look at this code. So we've got our sentence in. That's good. Nice descriptive name here. Oops. Keep doing that. I keep accidentally right-clicking. we've got our vowels dictionary, which we're returning. So here's our accumulator. We've got a vowels string, A, E, I, O, U, Y, and A, E, I, O, U, Y. Good, this will work. We've got IDX list, which I suspect is sort of the issue. And then for index and value in enumerate the sentence. So real quick, before I proceed, let's just make sure we're getting what we expect here. Print IDX and val. So I expect to see the index followed by the value, which the value will be the letter. Okay, HELLO, THERE, and 0 through 11 consecutively. Good. We're good. Let's get rid of that print. Actually, I'll just do this. Okay, so if the value is in vowel, I'm just going to call this, I'm going to call it vowels. That's just a little semantic, that'll just help me think about it. So if the value is in the vowels, then IDX list append IDX, and then we say vowel dict sub val equals IDX list. Okay, cool. So I see this confirms what I was thinking. So what's happening here, and probably to many of you watching this may be clear, but let's just clarify this just so we, to anybody who's not quite clear about what's going on here. I'm reading this vowel dict as our intended target to accumulate onto. And IDX list is what's being appended to every time we find a value that's in vowels. Now what we need to do is separate out the vowels that are in, we need to separate out the indices that are related to each given vowel, right? So what this is doing is it's appending to one master list that holds all of the indices for any vowel, and then that list is being assigned, that list that holds all of the indices for any value is being assigned to each individual vowel. So what we want to do here, I'm just going to comment out the IDX lists for now. We're going to get rid of that. And I'll delete them when I'm done, but I just want to leave it there so we can compare and contrast when we're done. We can check if the character, and I'm just going to call this, is it char? Excuse me, I always forget if it's char. Yeah, it's CHR. Okay, so I'm going to call this char for character. So if the character is in vowels, then we know it's a vowel. Now what we want to do is append the index to a list that is unique. The list has to be unique to this key in this dictionary, right? So what we want to do, what we want to end up with is something that looks like vowel dict subchar dot append. This looks like I'm appending to the dictionary, but I'm not IDX. And admittedly, this is not yet complete, but what I'm trying to show you is a lot of times you write code that you kind of work up to, right? So if I write this code, this does not yet append to a list. There is no key or value. There's no key in this dictionary currently called char. We haven't created it yet, and there's no list of that key, obviously, because the key doesn't even exist yet. We'll cross that bridge when we come to it. So I'm just showing this to say whatever we end up with, we want to be appending the index to a list where the list lives in this key. So to be clear here, we want to have a dictionary with a string key, we'll just say E, and a value that is an empty list, and we can append to that list, right? So it seems a little funny, but it'll work. Okay, so we've got our dictionary, we've got our sort of our destination, this thing that we want to do and we have to work our way up to. The reason we have to work our way up to it is, like I said, this appends the index to the list at char, but it does not create char and the empty list in the dictionary. This does not initialize those things in the dictionary. This will just append to it once it exists. So let's just comment that out for now. So I think what I want to do is just say, first, before we append to this thing, we need to make it exist. So what I want to say is, if char is not a member of the keys of the dictionary, then we want to create it. So we'll say if char not in, we'll do a test for membership, sort of a negative test for membership here with the not. So we'll say if char not in, what is it, vowel dict dot keys. Some of you may point out that we don't need dot keys. That's true, but I'll just, if you don't know what I mean by that, just put dot keys after it. If you want to check the keys of a dictionary, this will sort of give you like a list of the keys of a dictionary. It's not quite a list, but it's like a list. You can think about it like a list. So if you want to check if something is in the keys of a dictionary, you just use dot keys after it, and it's a good practice. I consider it a good practice. Some may disagree with me, but this will, to me, this is just clear code that just expresses clearly what you intend to do, which is to check if char is not a member of the keys of the dictionary. So if char is not a member of the keys of the dictionary, we want to add it in. We'll say vowel dict sub char equals empty list. Okay, so if I'm just gonna run it like this. Let's just see what this does. So this should give us the output. So this, you can see now we have a dictionary with the keys and two empty lists in it, right? So these are two different lists with two different IDs capable of holding two different sets of values, two different groups of values, right? They're different lists. So being lists, we can append to them. Being different, we can append to each one individually. So think about how I would access, in order to append to this list, we need to first think about how we can access it. And I kind of gave the giveaway here, but let's pretend we're building up to it. We can say, so how would I access each of these lists? So let's just do a little print test here just to confirm. So we'll say char. Oh, this is, that's actually a little confusing. Yeah, so let's just print vowel sub char, vowel dict sub char, just to make sure that we get a list printed out. Cool. So you can see we have 4 empty lists. How do we know they pertain to each key, though? Let's just print char next to it to make sure that we know which one pertains to what. Okay. So this one says E, that's the value of char. E has an empty list. O has an empty list. E has an empty list. E has an empty list. Good. So this proves that we know how to access that list. We know how to, name it and specify the list that we're talking about. Now we can just straight up append to it. Dot append IDX. Cool. And that's the line that I wrote before. Cool. So this will give me E with 1, 8, 10 and O with 4. We're expecting E with 1, 8, 10 and O with 4. Cool. So this is a good solution. It has a lot going for it. I kind of I said I wouldn't delete that other line there. Let's just compare this with the original code, just to kind of compare and contrast here. Oops. Excuse me if I can get Slack to let me copy that. Okay. So let's compare it with the original code. So I did like a little bit of a formatting changes here. Let me do a little more there. Just kind of formatting things in the way I prefer, but that's sort of minor, more trivial. But I would say I kept most of the structure of this. So I would say this solution was most of the way there, but we've got this IDX list which holds everything, and the big trick with this was how do you separate from having one list into having separate lists for each key. This particular problem where you have a dictionary of lists. This is a good problem to work with. This is a good sort of data structure where you have a dictionary of lists to work with, because it allows you to sort of practice with both of the sort of, the bigger types that are in the basic types of Python. And particularly dictionaries that have lists as values are common enough that specifically dictionaries of lists are good to know how to work with. The big trick with this, with working with a dictionary of lists, is realizing that you can append to the list inside the dictionary. Oops. Right here. So this is the big sort of thing, and I think for a lot of people it can feel really weird to like I said this before, it can feel like you're appending to a dictionary. To be clear, you can't append to a dictionary. This is not appending to a dictionary. This is appending to a list, just a normal, regular old list. And it's just that list happens to live in as the value of this key in this dictionary. So the list we're appending to is a value of the key in the dictionary. Cool. I noticed some of you that I might be explaining something that's pretty obvious, but I'm sure that perhaps some of the people on stream at the moment will not know that, so I just want to make that clear, because it's a good this is a good problem, and it's good to clarify that now. Cool. All right, we've got a few more questions. You know what? Actually, I did not submit my solution. Let me make sure my solution is actually going to work here, because that would kind of defeat the purpose. Is it this one? Yeah. Okay, let's just verify that. Okay, that works. Let's just really quickly see what they did. They make a vowel dictionary. They enumerate the input. They run a for loop through the input and enumerate the input. I was wondering if this would come up in the tests. It looks like the tests don't require this, but this is actually a good practice. If we have like a capital O or something, for example, this is going to change our output. So now notice lowercase e, lowercase o, and capital O are all considered different characters. So if we want to, and I would imagine with a problem like this, to me it would make sense to group capital O and lowercase o as one character, right? It just makes sense to group those. So to do that, we would do sentence dot lower. And lower, this doesn't change the string. It doesn't actually alter the string. Like append alters the list by adding something to it. Dot lower, it can be easy to look at this and say, that changes the string to a lowercase version. It doesn't change the string to a lowercase version. What it does is it returns the lowercase version of the string, but it doesn't actually change the string you call it on. So we can have sentence.lower, which is going to return a lowercase version of the string, of the sentence, and that will include capital O with lowercase o. And I was wondering if this would come up in the tests, but it looks like the tests will accept it either way. But I would personally consider this a better practice as well. So it's good that they did that there. Because I was doing it and I forgot about it at the time I submitted it. So okay, so this is just checking the vowels directly. If the char is in A-E-I-O-U-Y, same sort of deal. In the solution we submitted, we just broke that out into into its own variable. In this case, since we did dot lower here, we don't need to check if it's in, or if the character is a uppercase character, since within this loop we're not going to be working with any uppercase characters anyway. So this works to just check lowercase characters because we did dot lower, and that's going to give us all lowercase characters. Then we see if the character is in the value dictionary. This is the same check that I did, only in reverse. What I did is said if it's not in there, and I always do this, like this is my preferred method. My preferred approach is to say, if it's not in there, add it, right? And then do my primary logic. I would consider this what I would call primary logic. The sort of main point of the logic. The main point is to add the index, append the index to the list at the key in the dictionary, right? So this is kind of the main thing we're working up to. These two lines here just support that. They make sure that this is going to be possible, right? So they're necessary. All this is necessary and still kind of part of I would say part of the primary logic actually, but this is sort of what we're working up towards, right? So I always prefer to do this. It's just what I'm in the habit of. The way I think about it is, if it's not in the dictionary, add it in, and then you just let the rest of the logic continue. This is doing it a little differently, although it's in the same. It's the same idea. Let's just look at this really quick. Well, actually, we'll look at it here. So it says if the character is in the dictionary, then it's going to do the append. Oops. Then it's going to append to that list. If it's not in the dictionary, so if the character's in the dictionary, then it'll do the append. Else, it's going to add it in with the current index already in it, right? So there are multiple ways to do these same few lines. I just think my personal preference is it just reads better like this, but it's all the same. No best practices or really better way of doing it. But here's another solution. Actually, yeah. So this solution uses .get. I'll leave it to you. I actually realize I've spent a bit of time on this, and there's a few more questions. So sorry to keep you waiting if you have a question in there. Cool. Give me 1 second. I'm gonna mute my mic for 1 second. Sorry about that. Okay, let's get back to it. So we've got another, it looks like another dictionaries problem, removing keys or something. Let's take a look at this one. Okay, so this question comes with some explanation. It says, can we revisit dictionaries removing dictionary keys and values number 3? And then the link we covered this on Friday, but when I went to do the problem, one of the conditions was not met. The function should, says, quote, the function should remove the second occurrence and third and fourth of the values, not the first occurrence. Okay. Okay, I see. So we've got some code with this one. Let's take a look at it. Let's see what's going on here. Okay. So I don't fully know this problem yet, but I think they're saying we did this on stream on Friday, which I remember doing this one fairly recently. Looks like we've done it before. Okay. I'm going to delete my solution and just pop it down here at the bottom, and we'll just take it step by step from the beginning. I'll pretend like that's not there. So why don't I copy in, here, let's do this. Write a function called delete dupes. Oh, wait. Oh, okay. It is doing that. Weird. Okay. This function should, just do that. This function should take a dictionary as an argument, go through the values inside the dictionary and remove any key value pairs where the value occurs more than once inside the dictionary. This value should remove the second occurrences and third and fourth of the values, not the first occurrence. Interesting. You should make a copy of the past dictionary. The dictionary method.copy makes a copy of the dictionary. It is applied to this lesson, covers how to copy dictionaries, and more here. Okay. So delete dupes. I suppose I could have copied that from the thing. Okay, so let's think of a test for this. So let's say let's call this my data equals a dictionary, and we'll just do something like A has 44, B has, B has 55, C, D, E, A. Let's just do that. C, D, E. Okay, so we'll say C has 44, D has 44, E has 66. 33. Okay, doesn't matter. Okay, so here's we'll use this as an input dictionary, and let's do print delete dups with my data, And for this, what do we expect it to return? Let's do something like this. So we expect it to return a dictionary with the duplicates removed. So we should have A, we should have B, we should have C and D removed, it looks like. So this is kind of funny to me. It's saying that it needs to remove the second and third occurrences and so forth. Dictionaries don't have order to their items, which are key value pairs. They're not stored in order, to my knowledge. So I don't know if I'm mistaken about that, or if this question is mistaken, or if I'm just simply not understanding. But we're just gonna proceed as normal, and if that becomes a problem, I guess we'll cross that bridge when we come to it. Cool. Okay, cool. So we've got delete dups takes in dictionary 1. Let's just real quickly, let's just run this and make sure. Let's see what we get. So I should expect A and B. Looks like A was also removed. So that must be what's going on. So, yeah. Interesting. Very interesting. Well, now I'm curious how I did this. Yeah. Okay, that's what I was, okay. So what we expect is A, B, and E. What we got was B and E. So it's removing all of the keys that have a duplicate character, not just one of them. Cool. And let's just make sure that this is not mutating its input. I don't believe it is, but it's always good to just check. So we'll see if the dictionary is being altered. No. So the original dictionary is in good shape. And that's what we want. Okay, so the way that I can think of to do this is to, well, let's see. I actually need to, this is funny. I wrote this code like on Friday and I'm like, what did I do? Okay, I'm just gonna look at my solution here. I call the input D in, and then often you might hear me say like, don't use single letter variable names. I try to put that with a caveat nowadays, like, don't use single letter variable names unless there's like an established sort of thing that means. If I'm working with a dictionary in a small problem, I'll often just call it D because I know what that means, and I do that consistently enough that I know what it means. Same thing with K and V here. But so the dictionary that we're going to return is just D, which is a copy of the input. So we kind of forget about the input and we can just move on. We make a scene vowels list, which we append to, and then I'm checking if V. We go through. Excuse me, I'm jumping up ahead a step. For KV in dictionary.items, and we check if V is in scene vowels. So we just check for membership here, and if it's a member, then we delete it. Otherwise, we're gonna, or if it's a member, we delete it, and then we append it either way. Cool. So yeah, so let's just look at this solution. I want to see if we can make this solution work. Not quite sure how, but I think we could do it. Well, I think we could give it a shot. So dict2 is a copy of dict1. That's fine. Vowels is a list of dict1 values. Okay. I see. Okay. And then for key value in dict1.items, so we're looping through dict1 and modifying dict2. That's good. If the count is over 2, then we want to delete it, unless this is the first time we've seen it. Unless it's the first time we've seen it. So I think I could make this solution work if I could build in something that would give us a signal on if this is the first time we've seen this, not the key, because every key is going to be unique, but the value. So this is the first time we've seen this value. Okay, so I think what I need to do is, like in my other one, create a scene vowels list. We'll just make an empty list, and I'll just append to it at some point. Where I append to it's going to matter. I think I need to append to it right here. Which I think is where I did it before. So scene vowels append value. Okay, now I need to check it before we delete. So we'll say if the count of the value is greater than 2, we'll just do this in a simple way. We'll say if value, is it not in scene vowels? Then we want to delete if it's not in scene vowels. I don't know. We'll just try it out, see if it works. B, C, D. That did like the exact opposite. That deleted A but left in the duplicates. Okay, so maybe we need to invert this. Okay, I think that's what we need to do. I think A, B, E. Okay, good. So if the value is in scene vowels, of course, right? Yeah, that makes sense. Then we delete it because we've already seen that value before. Okay. The thing is, I think that just means we can get rid of that. We'll see. Yeah, this is just starting to turn into the other, like this. I'm trying to make this solution work with count, but I think if I'm gonna do this scene vowels thing, I think we just don't need count because it's working without it. So I think it ultimately is just destined to turn into this solution in some way. Yeah, at least the way I'm thinking of it. Somebody else may approach this problem differently. This is what occurs to me for how to solve it. So I won't say that my solution is the only one. It's just the one that's coming to mind at the moment. So to me, I think I need this like running record of values that I've seen before if I don't want to delete the first occurrence, that is. If I want to delete all occurrences that have a duplicate, then yeah, I mean, we saw how to do that before. Cool. Let's just make sure that solution is actually going to work. The modified one, I know the other one works, but we'll just see. So just to be clear, I think I did just clarify this, but just to be extra clear, I think the big difference here is the scene vowels list, because that gives us a record of what we've seen before, values that we've encountered through the loop before. Scene. Okay, cool. Good. got another question. Adding key value pairs. Let me just kind of clean up here. Oops, was that? Yeah, I wanted, what? Yes, that is, I wanted to delete that. Okay, and then this I'll just save here. Bam. Okay. So having trouble with challenge 3, code is replace doubles. Ah. Another sort of duplicates related challenge. Looks like this is, looks like I solved this in a ridiculous way just for fun before. Okay. Wonder what that was about. Okay, write a function called, oops, actually let me grab, was there, yeah, there was some code with this one. Let me grab that. We'll see what this code does. Okay. Write a function called replace doubles. This function takes a sentence as an argument, then checks for any double letters, for example, A or TT, and replaces the double letters with just a single instance of that letter. I.e. capital double A becomes capital A, and TT becomes T, for example. Okay. I think that's clear. Let's see. This function should be case sensitive. Got it. Preserve that each case, da da da. Oh, so we should do this for spaces as well. Good to know. All right, so let's think of some tests. Print, replace doubles. Replace doubles. So let's just do something on the nose here, like AA space space should give me a string with A space. Let's do AA space space T I don't know, AT should, okay, so this should give me A space TAT. So even though T shows up more than once here, it's not a doubled letter, so that's, we don't expect it to be doubled. I'll just leave it. This seems like enough test. I might need some more tests, but we'll just do one for now. It's good to start simple. Looks like it works. Okay, so I don't know. Let's see what happens if I submit it. It's probably some edge case that I haven't anticipated, or maybe I didn't read it. Okay. So here are some letters. Huh. Okay. So let's see. So if we look at, this is a pretty well-written error. So let's take a look at this. Let's take a look at this error and let's dissect it together. So this says, oops, I'll just comment that out, put that in a big string. It says traceback, most recent call last, we can remove that. We can remove, we don't care about the file where the test, this is the actual file where it's happening. The error is happening in a testing file that's meant to test the function. We don't really care about that. Here, this is where things start to get interesting. So if we look at this is a call to our testing suite in Learn, right? Self.assert equals, takes main, which is where the file where your code is. Internally, it's referred, that file is called main. Replace doubles, which is the function that we're looking at. So if I made this look like, all right, let's do this, print. All right, I'm turning it into the sort of the tests that I use here. And I took this, right? Yeah, actually, let's just do that. Okay, let's do that. Okay, so this is just basically another kind of test, right? It's just it's done a little differently. Oops, deleted one of the parentheses there. It uses some more formal testing tools from a testing suite that's in Python. The tests that I'm showing you are just simple prints of the function. We're just printing out what it returns. So this says we get an assertion error, which just means these two things aren't equal. It says HRAREE, some letters, is not equal to here are some letters. So what I presume is happening is this is what it's expecting. Is that true? Yes, so that's what it's expecting. Whereas this is what it found. So let's just confirm that. And it kind of expounds on that here, right? It says minus this, which is like, we don't need this, but we do need this. That's what that means. So it's giving us a minus in the columns where it's finding things that we don't need here too. So you can see this is trying to show us, if you look at this, I won't go into too much explanation on this, but if you look at this, it's trying to show you what things need to be removed and what things need to be added according to what it's expecting. So let's just run this. I'll actually comment that out. Run this. HRAARE. Okay, cool. So this one is not passing. Let's see then. Let's see what's happening. I do not understand this input or this output, but I guess we'll just find out. Okay. I wonder, I wonder if this is changing what it's iterating through. I bet that's the case. Bet you that's the case. So this is a hunch, kind of a bit of a suspicion. But what I see here and what I suspect is happening, so when you loop through something, it's easy to think that the thing you're looping through is canonical in the loop. Like the object being iterated through is safe because you're looping through it. And that's not actually the case. You can loop through something and change the thing as you're looping through it, and the process of changing it in the loop changes what the next successive iterations are going to give you from what you would have expected given the original input. That's a lot. I suspect that that's probably sounds like a lot. Let's see if I can kind of demonstrate this. I'm trying to think of a good way to demonstrate this. Apologies for the lighting in here. Gosh, I gotta figure out something. Let's get a lamp in here or something. Anyways. Okay, minor distractions. Let's see then. So I suspect that that's what's happening here. So I wonder if we can just pare this down. So where's the first place that we see an error? Okay, so the first place where I see something that's out of place, our output says HR and our input says HERE, or I mean our expected output. Our actual output says HR capital A, and our expected output says HERE. And let's just put these next to each other since we're working on this particular problem. Just kind of juxtapose them next to each other. So what I want to do is really just kind of pare this down. Let's just pare this input down to just this. Well, we'll comment that out. And actually, let's bring these up here too, and then we'll make a little mini version of this. And this might make it easier to think about. Wow. Okay. That is amazingly interesting. That is really, really interesting. Okay. So we reduced the size, and this actually matches now. Okay, so this makes me think that maybe something else is going on. Okay, so that actually matches what we expect. So let's just add back in, bit by bit, each one of these until we find out what's going on. Okay, I think I know what's happening here. Since we're only removing the first instance, I think we're just removing the first instance so we encounter something that we removed before. Okay. So let's just add in. So what I'm going to do here is here's the input from the problematic input that's giving us an unexpected result. And here's the beginning of that input, but for some reason doesn't give us a problematic result. I'm just going to add in character by character, one at a time, until I start getting output that I don't expect. So we'll do one space. Okay. Oh, there's an easier way to do this. Excuse me. Okay. Let's leave that space off. I'm just putting it in a list so I can see the quote marks around the string. When you print a string off, it unfortunately doesn't show you the quote marks, so I just want to make sure that I can keep track of the quote marks because that'll tell me if there's a trailing space or not. Okay, so we expect one trailing space. Ah, look at that. Would you look at that? We found the culprit. Okay, so no trailing spaces is good. One trailing space is good. Two trailing spaces, and what we expect, so two trailing spaces, and what we expect is one trailing space. But what we get is two trailing spaces, but that previous space is removed. And I think it's because we're saying replace char with nothing once. I always have to remind myself how this works. Huh. Yeah, I always have to remind myself how replace works. So let's actually look at this example string. I have to print this off. So print dot replace, and we'll just kind of model the behavior here. So we'll replace capital H with nothing. And is that going to do both the H's? I think it will. Sure does. So we want to do the first occurrence of it. Okay, now is this asking? Yeah, this is asking for to use the replace method. I think I would do this in a different way. That my tendency would be to do something that doesn't involve replace, but we'll try to do it with the replace method. Okay, cool. So instead of replacing the first instance, what do we want to do? I am tempted. I'm going to look at my prior solution. That is a giant mess. All right. But I did use replace in the prior solution. So let's see here. So let's do I'm just going to pare it down to the one that I know is problematic. So we're getting this. When we should be expecting this. I think what I need to do is start over. Sometimes I'm like looking at, especially if it's somebody else's code, and I'm like in that, like however they're thinking about it. Actually, I'll just copy it back in if I need it. Like I'm in however they're thinking about it, and then it's like hard to like shift from that perspective into a different perspective. So I'm just going to kind of follow my process, my normal process here, and we'll see what happens. Okay, cool. So let's do txt for text equals empty string. I think I'm just going to do a kind of try to do this with a really vanilla accumulator pattern. Txt, and then we'll go for a replace approach as well. So we'll say for char in sentence, print char. I don't need to, well, we'll print char. Let's just do that real quick. Get an empty string. Okay. So we do need a previous. We do need to be We do need to get a previous. And I think the way I'm going to do this, I'm going to use zip. I'm going to say prev and char, and I'm going to use zip, and we'll do sentence sub actually, I think it'll be easier to do like this, sentence sub, and I'll do a slice starting from the beginning. Okay. So let's check this out. Let's print prev and char. It's more like char and next, but yeah. So you can see we have these kind of staggered, right? So we get the things sort of staggered against each other. This doesn't look staggered, but it is, since it's the first thing and we start with a double letter. If I did hi, something like that, that might make it look more staggered. Okay, but you can see the second column, char, is staggered against the first column because it starts at the next character. So I'm calling this prev and char. That's what the original how the original question was structured. That's how I structure things. Although it might be more accurate to think about this as like char and next, since the first one isn't really the previous one, it's really the main one, but it doesn't really matter. It's a semantic difference. We can think about it however, whatever makes sense to us. And I'm going to continue with prev and char. Okay. So I think all I want to do is just say if prev equals char, continue. Otherwise, we're going to text plus equals, I guess it needs to be prev. Okay, I do want to change this. I want to change it so it's actually prev and char. What do I need to do? I need to go up to, I'm worried that I'm going to lose a character if I do it this way, though. Whatever. Not that worried. Sentence, I think I just want to go up to -1, which is the end non-inclusive. I think that's what I want. Let's just confirm that again. Print, I should see the same staggering pattern. Prev and char. Because I want to add char. I want to make my code semantic. So these are equal. Ah, alas. Let's just add that in there. So I'm not getting a... Oh, wow. So do I need to do -1? Is that, it seems like it's going... Yeah, it is. I am losing a character this way. Dang. Ugh. If there's a way to do this, I'm being silly right now. Can I just do this? I'm just being silly. That totally works. Okay. The funny thing is I still need to add prev. now I'm wondering if I just switch the order. I think I need to call that. Sorry, I'm picking a nit about the semantics of this when really I have it solved. I just want it to read perfectly. It doesn't. I don't even need to be worrying about this. Yeah. Ah, interesting. So I do have an edge case in either direction. So in this case, I need to. I'm actually losing the first character. But I wonder if there's a way where I can do something like this. If prev equals char, we'll append char, else prev. I might need to switch the order of these two, or this might also just not work, but we'll see. Okay. That has more problems. I don't want to enumerate here. Okay, so this, I think this works. The funny thing is we're not using the replace method, which I kind of think was the point of this, but just a quick plug for the classic accumulator pattern here, folks. This code is boring, and I think it's going to work. I'm not sure, but pretty sure it will work. No, it doesn't work. Ah, alas. That's okay. Oh, I'm not handling doubles at the end. Alas. Dang it. My simple code may have failed me. I may need to make it more complex. That is par for the course, though. Okay, so this says takes in letters. Yeah, that's a good point. So I'm testing with a double at the beginning. I should be testing also with a double at the end. Let's do this as well. I might just have to create a special case for the beginning and the end. The beginning and or the end. I think probably just one or the other. So that's okay. All right, I'm going to abandon zip. We're going to do something else. We're going to do enumerate. And we'll call this IDX. And we'll scrap the old solution entirely. And we'll go for, we'll just enumerate the sentence. Wow. Okay. And then we'll say prev. We'll say if IDX equals 0, then we know it's our first trip through the loop, and we'll just continue. Otherwise, we'll say prev equals sentence sub IDX minus 1. Now let's print char prev. Okay. So isolate this down to just one test at a time. All right. So Yeah, I think this is better because we actually get the full string represented in char. Oh no, excuse me, that's going to be... Ah, no, we don't. We still are one short. Okay. Right. So perhaps what I want to do instead is just first trip through the loop. We'll just text plus equals char regardless. We know we need to add it in there, and we'll assign prev, and then we'll say if char equals prev, then what? Text dot text plus equals char. Okay. No. Oh wait. Not equal. Sorry. Here are there. Okay. Let's see if it passes the next one. Letters. All right. All right. Let's see if this works. I'm going to be less cocky this time. Let's just see. Okay, cool. So here is again, another boring solution using vanilla tools. So why am I saying this? Replace. So I know I'm going off the rails with the intent of this function. It's funny because I did solve this before using replace in this crazy comprehension. I could reverse engineer this back into a list or reformat it so it's easier to deal with, but what I wanted to show here is replace is what I would consider a subtractive solution, where you start with a full thing and you replace or remove elements until you pare it down into what you need. I think there are optimization cases for solving a problem in that way. However, if your goal is to just like produce a working solution, this works. And what I'm referring to when I'm saying it's boring and it's vanilla, those are kind of good qualities often in code, right? Like this is a very simple, straightforward accumulator pattern. If you're good at accumulator patterns, you can do all kinds of things that you're not supposed to do with them. Right? We're supposed to use replace, and we'll dissect that other solution here in a second. But we can also just take an additive approach to this, right? And we can approach this with an additive solution. So rather than a subtractive or a reductive solution, we can take an additive solution. If you're having a problem, if you're having trouble with a given problem, take a simple additive solution to it, and that'll help get you through it, get you to the end of it, right? So how is this additive and the other one's subtractive? What I'm considering additive here is text, which is what I'm using as my return. So txt, just we start with an empty thing, and we go through and we enumerate the sentence. We're just enumerating so we get the IDX, mostly so that we can assign previous to the element at the current index -1. Since we're doing that, we don't want to compare the current index, when the current index is 0, 0 minus 1 is -1. which is a valid index to sentence. And if we do sentence sub -1, we're going to get the last element in the sentence, the rightmost element of the sentence. If we got the rightmost element and assigned it to prev, we would be comparing the current character, which is the first character, to the previous character, which is the last character, and that's not what we want. So we want to just skip that first iteration by saying if the index is equal to 0, the index is equal to 0, we don't want to subtract 1 to it here, right? Because that would give us the last element. So if the index is 0, we want to continue, and I needed to add this text plus equals char here just so that we could add in the first element, otherwise we'd be skipping it entirely. So whatever the first element is, I want to add it in, regardless of whether it's doubled or not. And then we'll continue, meaning we won't run this code in that iteration of the loop. We'll go, IDX will be incremented, char will be advanced to the next element. We'll check IDX, which is now 1, is equal to 0. That's going to be false, of course, because 1 is not equal to 0. Then we'll have prev equal to sentence sub 1 minus 1, which is 0. That's going to be our first element. We already added in our first element, so we added it into the output, which is called text here. So we check if char and prev is this first element that we already added in the previous char. If char and prev are not equal, then we'll add it in. So we're kind of safe. We're safe to add this in, because if it's not duplicated, then we'll add the next character in. If it is duplicated, then we won't add the next character in. So it's safe to do that line 5 here. Cool. Let's actually do it in the way that they wanted us to do it, with replace here. Oh God, I don't even want to, I just want to look at the example. Let's just see what they were doing. Okay. Right. This is kind of a, yeah. I remember seeing this solution now, and it's kind of like, there's sort of a trick here, because you take in the string as an input, but this is actually going through a list of chars, which is just the whole alphabet plus a space. So the trick here in the formal solution that they're giving is to go through the whole alphabet and check. So you say 4-letter in chars. That's, I would have called that ABCs or something. Chars is a little too generic there. We could be specific and call it alphabet or something. So we could say for the letter in the alphabet, new string equals new string. This is an incrementation. It doesn't use a plus equals, but it still is an incrementation, or excuse me, or a accumulation. And it'll say new string equals new string dot replace the letter times 2, which will double the letter, with just single letter. So that's a way of doing this. And the trick here is to go through the entire alphabet plus a space. That space is kind of sneaky. It's in there at the very end, but we want to include that. So the entire alphabet, or a collection of all the valid characters that we would want to use in this. And then replace all the double letters with single letters based on what's in the alphabet. Cool. So that's a great solution. It's not what occurred to me naturally, but to be honest, I've never been let down by this pattern. Like the positive, quote unquote positive or additive accumulator pattern, where you start with nothing and you build up from there, this just doesn't let me down. It just gets me working solutions. So yeah, I want to kind of showcase this as like if you just need to get from point A to point B, this just gets you there. Cool. Yeah, we won't go through that. That is just hot garbage. All right. This is actually kind of a neat solution, but it's just, I mean, look at it. It's hard to look at. To me, it is, at least. It's a lot. It's technically a one-liner that's broken up onto multiple lines, and I remember giving this one as a example of like, yeah, you could do it this way. You know, this is a Code Wars problem. This would be like the best practices sort of solution, kind of. But it's like, this is just so hard to read. It's very ridiculous to me. But anyways. Cool. I think we've got one more question. We are getting towards, I don't know where the time went today. We're going to do this one more question. Apologies if I keep making anybody wait. Oh, it looks like that's it, actually. So, there we go. So it says this one's number 7. Get all words. Let's just verify that. Okay. Get all words. Not sure. Huh. Okay. So it says that this was the code submitted. Let's just read through this and see what we expect. Okay. Write a function called getAllWords. Given a sentence, getAllWords returns a list containing every word present in the sentence. Okay. If we get an empty string, it should return an empty list. Looks like we've got a test here. That's just ready to go. We don't even need any preparation to it. Oops, still got this activated up there. Let me, I didn't realize that. Let me move this up. We'll just use this one. Radagast the Brown. And it looks like it's failing, I think, from the error that was supplied by the question asker. It's failing on empty string. Yes, okay. So notice we get a string with, this is not an empty list. This says if given an empty string, it should return an empty list. So I would say, I think we might need is that gonna do it? No. So real quick here, casting this as a list I get why. I mean, that is what this question is asking for. However, split does just return a list. String.split just returns a list, so it's just technically unnecessary, although correct in terms of what the question is asking for. So this is going to return if we split on an empty string, if we split on spaces, it's going to give us the string back where we split on spaces. There were no spaces to split in here, so I think we just need to hide this under condition. We'll just say if not string, we'll just do that, and we'll just say return list. Let's just try that. Yeah, so we just need to make an edge case for this one. So just to be clear, if not string, what this does is it returns, or it, oh, excuse me, I need to explain truthiness and falsiness, right? So it can, Python can interpret various states of various data types as truthy or falsy, right? So an empty string is considered falsy, and what we want is a condition that is true when the string is empty, which is in a falsy state. So we say if not string, that's basically like saying if there's not anything in the string, then we'll return an empty list, right? We want it to be true when there's an empty string, so we can run this this here. We could do something with an if-else, like I don't know. But this to me seems like the edge case, and this seems like the primary case, so we'll just do that. If you really want to fit it on one line, I won't go in too much into ternaries, but you could use a ternary. We could say string.split if string else empty list. I think that should work as well. I always kind of get funky with ternaries. Yeah, that's how you do it. Okay. So let's just do both the tests. Oops, this should be. Alright. That should do it. Oops. Correct. Okay. All right, cool. That'll be the last question for today. Thanks for everybody who asked a question, and even if you're not, thanks for viewing, and you know, leave a like if you liked it. If not, then you know what to do. Obviously, you can subscribe, and if you're not in the Galvanize prep channel, come sign up, and you can DM me and ask me questions there if you like. Yeah, do feel free to let me know how the stream quality is, how the stream is in general, if you like the format, if you don't like the format, if you have any ideas that could help us improve, or if there's anything about the stream that's just not working for you. I am open to you know, polite and constructive criticism, because I want these streams to be as good as possible. And right now I'm looking at my camera and I'm like, I still look like I'm in a dungeon in here. I don't know why. I feel like I need to justify myself every time. Like, I promise this is a normally lit room. I'm not really sure why the lighting is not coming through in the camera, but anyways, cool. Yeah, I will see you all on Wednesday in Premium Prep, if you're, or in study hall, for the next study hall. If you're in Premium Prep, then I'll see you